All right, this is the point in the chapter where we talk about specific discrete distributions. This one is the only one that the SL students need to know, but there's one more that the HLs will need to know as far as discrete distributions go. So this one is called the binomial distribution. What we need to be able to do, because you won't always be told what kind of distribution it is, you need to be able to determine whether it is a binomial distribution or not. So we will know it's a binomial distribution if there's a set number of trials, so the event happens a specific number of times. The probability of being successful is the same with each trial, so you would not want to use this whenever you're drawing marbles out of a jar, let's say without replacement, because the probability does change. If you were drawing marbles out of a jar with replacement, then you would use binomial distribution because the probability stays the same every time you draw out a marble. And it's called binomial because there are only two possibilities. Bi means two, so there's only two possibilities. You can either succeed or you can fail. All right, so that's how you know that something is a binomial distribution. Let's talk about a specific example about rolling a die 5 times, and I want to know the probability that I roll exactly 2 2s. Okay, the other 3 rolls can be anything else, but 2 of them have to be 2s. So I look at the probability of being successful, and I call that little p, and that is 1/6. And so little q is the probability of failing, which is 5/6, meaning I can roll anything else other than a 2 in order to fail. So I need to have exactly 2 successes and 3 failures. Now notice that they don't have to happen in that order. I'm not going to necessarily be successful on the first 2 rolls and then fail on the last 3. So I need to go back to combinations to figure out how many ways can I arrange those 2 successes and those 3 failures. Well, if I have 5 trials and 2 of them have to be successes, then there are 5 choose 2 ways to do that. Okay. Now, the probabilities of being successful and failing, probability of being successful twice is 1/6 times 1/6, which is 1/6 squared. And then the probability of failing 3 times is 5/6 to the 3rd. All right, so if I combine all of that together, I get 5 choose 2 times 1/6 squared times 5/6 to the 3rd. And then if I figure out what all of that is, 5 choose 2 is 10, 1/6 squared is 1/36, 5/6 cubed is 125 over 216, and if I simplify all of that, I get 625 out of 3,888. So that's the probability of rolling exactly 2 2s. So let's talk about the general case now that I've talked about a specific example, and I'm going to give you a formula that will work for these. So we're going to let n be the number of trials you have, p being the probability of success, and x being the number of times you want to succeed. So this is the formula you would use. The probability that you are successful x times would be n choose x, the number of trials choose the number of times you want to succeed, times p to the x, so probability of success raised to the x, and then probability of failure raised to the other trials n minus x. So that's the formula that you will use to do any binomial distribution once you know it's binomial. Let's talk about what expectation or expected value or mean would be for this distribution and what variance would be. Now you could figure that out using the formulas that I gave you in the previous video, but once you know what they are, I think you're going to want to use these instead of going to the general case of what expectation would be and what variance would be. Your mean is going to be n times p, the number of trials times the probability of success. That's it. And then your variance is going to be as simple as the number of trials times the probability of success times the probability of failure. That's it. So it will help you to remember those formulas, and they only apply to a binomial distribution, but if you know them, you might as well apply them rather than using the more complicated formulas that I gave you in the last video that apply to other discrete distributions. So the last thing I want to talk about is how to put this in a calculator. If you have a Casio calculator, there are 2 functions in your catalog, binomial PD and binomial CD. PD is for probability distribution, and that's really the only thing I've discussed in this video, where you have the probability of being successful a certain number of times. Binomial CD, the C stands for cumulative, and that means you want to be successful up to and including a certain number of times. So rolling up to and including 4 3s or whatever the situation is. It's kind of like a less than or equal to situation. So the 3 inputs that you would need for that are exactly the same no matter which one you're doing. X is the number of times you want to be successful, N is the number of trials, and P is the probability of success. And with those 3 inputs, it can calculate the probability of being successful either a certain number of times, which is what PD is, or up to and including a certain number of times, which is CD is. So if you have any questions, let me know. Otherwise, I will see you tomorrow.